Okay, we're going to look at a couple of the composite shapes on the sheet that I gave you guys in your package, and we're just going to look at a few of them, and we're trying to find the surface area and volume for some different shapes, and we're going to start with the sort of like the ice cream cone looking guy. Now, there's a couple things we need to take care of. First of all, we've got the shapes. We've got a sphere type shape, we've got a cone type shape. I am going to need to know the slant value eventually, so we can figure that out because this is just a right triangle from, you got the 5 centimeters for the radius here, and if you go straight down, that is also 12 centimeters like this, and that's just a right triangle. So using Pythagoras, I can find the slant is approximately 13 centimeters long, which will come in handy later on. All right, so if I want to start with the surface area type stuff, if I do the spherical type top thing, we can start with that first. Now, surface area for a sphere is 4 pi r squared, and so we can use the radius of 5 and we can find the surface area of the sphere, but then you'd want to cut it in half because we only have half of a sphere. So we're going to do this really quickly and generally, but if you do the 4 pi r squared for the entire sphere, find the surface area for that, and then you cut in half, you should get about 157 centimeters squared for the half sphere on the top. And then for the cone part, we want the surface area for just the outside part because this bottom or the top part here isn't actually shown. So if we just get the surface area for the cone type part, that is pi r s, and that's where that slant value comes in. So we have the pi, we have the radius of 5, we have the slant of 13, and if we do that, we will get a surface area of about 204 centimeters squared. And then all I'd have to do is add those two together, and you're looking around 361 centimeters squared altogether. All right, now if we did a volume type thing, all right, so volume for a sphere, of course, is 4/3 pi r cubed. But once again, find the volume of the entire sphere and then just cut in half. We only need half of a sphere. And if we do that, hopefully get 262 centimeters squared or cubed. And then we can do the cone. So for volume of a cone is 1/3 pi r squared times the height. So we got the radius of 5, the height is the 12, and we can then find the volume of that, and you should hopefully get about 576 centimeters cubed. Oh, sorry, that's all together. This part right here is around 314 centimeters cubed. And then the 262 and the 314 altogether will hopefully give you a total volume of 576. And hopefully all those numbers work out okay. All right, so next, let's just quickly look at this type shape right here. For this one, we are also going to find the surface area and volume. Now, once again, I'm going to need to do some stuff first. I'm going to need the heights of these triangles, and this is 3 centimeters down here, and then this goes across to make a right triangle, something like this. Now, this is 8 down here, so I know this is 8 over here, so that distance would be 4. So I've got 3, I've got 4. I'd use Pythagoras to find out my slant value, which is the height of my triangle, and that's going to end up being 5 centimeters right there. And I will need that for sure later on. Okay, so let's do the same type of thing. We'll find the surface area, and we're going to find the volume. Well, first I'm just going to do my triangles. Of course, triangles are base times height divided by 2, and if I got my base is going to be 8. My height of my triangle is 5. So 8 times 5 gives me 40. Divide that by 2 gives me 20. But I've got 1, 2, 3, 4 triangles because it's a square at the bottom. It's a square base, so this is also a square. So all 4 triangles are going to be identical to each other. So I'm going to have 4 of those guys. So I've got 80 for total surface area of the top part, and then so that's my triangles. Then my sides, I've got sides that are 13 tall by 8 wide. So I'll do 13 times 8, multiply that, get the area, which is 104, and then I have to do 4 of those. So those would give me 416 altogether. And of course the bottom is just an 8 by 8 square, which gives me 64. So add them all up and hopefully get around 560 centimeters squared. Again, this is pretty quick, but just look at the values, try and get the values as best you can. Hopefully these numbers work out. Okay, so let's try the volume. All right, so volume for a pyramid like this, a square pyramid specifically, of course the volume is 1/3 base squared times the height. So you've got the base is 8 by 8, the height is 3. So you can put those into the expression, and hopefully the volume is like 64 for the pyramid at top. You got the box at the bottom, that's just going to be the length times the width times the height, so 8 times 8 times 13, that's just a big box. So you got length times width times height, and hopefully that'll give you 832, and then we would just add those two together, and hopefully it's around 896 centimeters cubed. Okay, so hopefully that works out for that one. All right, again, let's go to the next shape. This one's a little bit different. So this one's a cylinder with like a cone cut out of it. So this inside part here to be all hollow where the cone is. So let's look at the surface area here and the volume again. Again, we're going to need the slant value of the cone eventually, and so we can figure that out. Again, we can use Pythagoras. I mean, this is just it's a right triangle. We got this part here and up like this, and the bottom would be 6, and the height here would be 16. And using Pythagoras, hopefully this works out as 17.1 using Pythagoras, and that again we will use later on. Okay, so let's look at surface area. So first of all, for the cone type shape, I don't need the bottom part of the cone. I just need like the outside conish type part, which would be like the area inside of the structure, and that is pi r s, and that's where that 17.1 value will come in for the slant, and hopefully that's going to be 322. And I don't need the pi r squared for this part because that's just hollow, there's nothing there. And then I need the outside part of the actual cylinder, which of course when you unravel it, it'll actually just be a rectangle with a height of 16, and then the outside part here, the 2 pi r, the circumference is that length up here if this would unravel it, almost like a toilet paper roll type thing that's been cut and then rolled out. So if I take the circumference of this, which is around 37 or 38, I multiply that by the 16 here, I've got an area of around 603 for that part. And then for the bottom, there is a circle in the bottom, and if I do pi r squared for that, I should get an area of about 113. And I'll add those three up, and I should get 1038 centimeters squared for total area. Okay, so again, hopefully those numbers match up, and hopefully I haven't made any errors anywhere. All right, so let's try like the volume. Now for the volume for this one, we got two main volumes. We've got the cylinder and the cone, and we'll actually be subtracting them this time. I'm going to start with just the cylinder. And of course, volume of a cylinder is just pi r squared times the length or the height of it. And if I do that, hopefully get 18.8 centimeters cubed for the volume of this. And then if I do the volume of a cone, of course the volume of cone is 1/3 pi r squared times the height or the length. I've got the radius is half of this, that's the 6, that's the radius right there. The height would be the 16. So I put this all together, hopefully it's 603-ish. I'm just rounding a lot of these numbers off. All right, so now what I'm going to do with these two numbers, I'm going to subtract them, because I'm starting with the cylinder and I am going to cut out the cone part. So I'm just going to subtract the two, and if I subtract the two instead of adding them, hopefully it's around 1205 centimeters cubed altogether. All right, now on the second side, I've got a couple shapes. We're just going to bypass this one because it's very similar to the other one that we did. Again, you're going to have to use this to find the height using Pythagoras of the pyramid part on top. But let's go to this guy over here. It's got 3 different sort of shapes put together. We've got a few things we'll find. We will need the slant of the pyramid again, or not really pyramid, it's a cone type thing. So that's 3, that's 4, so we can use Pythagoras to find out this is going to be 5 meters. Alright, so let's find the surface area first. So the surface area, I'm going to start with the cone type part at the very end. I'm going to start with that roundish, conish type part. And of course, the same type of thing as before, find the surface area of the entire sphere, which of course is 4 pi r squared. Find the surface area of the entire sphere and then just cut it in half. And if you do that, I think the surface area hopefully is going to be around 100 meters squared. Okay, for the cylinder part, surface area this, again, you take the cylinder, you unravel it, it makes the shape of a rectangle. It's a rectangle that's 10 tall, and then the other part would be the circumference of the actual circular part would be the length. So again, this is your 2 pi r, your circumference there, so it's 2 pi r by 10. And if we do that, hopefully that gives you about 251 meters squared. And then for the last part, the conish type part, all we need is the area of the outside of the cone, okay, and that is that's the pi rs expression, and that's where the slant of 5 comes in. You got pi, you got the radius 4, the slant is going to be 5, so you're going to multiply those all together, and it should be around 63 meters squared. And then all I'm going to do is add them all up, and hopefully it's around 414 meters squared altogether. Alright, so now let's try the volume. Again, we're going to find the volume of the half sphere, use the volume expression for a sphere, find the volume of the entire thing, and then just cut it in half. And hopefully you're going to get 134 meters cubed. Find the volume of a cylinder. So you do pi r squared for one end, multiply by the length, and hopefully you get a volume of around 502 meters cubed. And then we'll find the volume of the cone at the very end. And so for volume of a cone is 1/3 pi r squared times h. Got the radius of 4, got the height of 3, and you put that all together, and hopefully they'll be around 50 meters cubed. And then we'll add those 3 together and get total volume of 686 meters cubed altogether. Okay, so again, this is pretty quick, pretty fast, but you guys have been working on shapes for a few days already, and some other sheets, and just sort of showing how some of these things can actually piece together. And hopefully all the numbers work out, and I didn't make any errors in my calculations, and everything will work out nicely.